Hey guys, Anthony here. This is a video in the series of videos that I want to create that links matrix algebra to statistics and econometrics. Today we're going to tackle a very important, simple, I must say, yet confusing concept as well. We call it maximal linearly independent set. What does this mean? It's a very simple concept, but at the same time it can be slightly confusing. So let's dwell into it. For the time being, let's forget about the idea of maximal. Just tackle this linearly independent set. Suppose I have a set S1 which contains three vectors: v1, v2, v3. Now, when I say that they are linearly independent set, so I'm just gonna write as LIS from now on, just to save space. When I say it's linearly independent set, what I'm saying is, if I take any combination of this, let's say I have A1 as a weighing factor for V1, similarly A2 for V2, plus A3 for V3, and the idea is to get 0, right? If there is nothing I could select to make it 0, only thing I could actually have is A1, A2, A3, all of them 0, then only I can make this combination equal to 0. Then I can say S1 is linearly independent set. Okay, very important idea here, right? So this is trivial, it's no use at all, right? It's just 0, 0, 0. But anyway, that's the idea of independence. Now, once you got that idea, let's move on to something what we call idea of a subset. So that means I take a small, the idea is this S1 is the big one, and we take a small subset of that. That means I'll create, let's say call that subset S2, and I'll only have V1 and V3. If this is the case, then this also will be an LIS. That means this set will also be linearly independent set. There's nothing else I can find in this A1 0. I need to have this and this, right, all equal to 0, right? So A1 and A3 has to be 0. So that also will be independent. The idea is, if a set is independent, like S1 that we just had a look, then any subset we take from that, a smaller number of vectors, just the way we did in S2, they will also be linearly independent, right? Now the idea, now it was a subset, right? Now what about if I want to go to get a superset, right? So my S1, right, my S1, you all know, was V1, V2, and V3, right? Let's make that V, right? Superset means, the idea of superset basically means I'm going to have a bigger set. Let's say that is S3. So to make it bigger, minimum I need to add another one here. So let's say I add V4. Now what happened if I add V4? What is S3 now? Is S3 still linearly independent? Right? Well, it really depends upon what this is. It really depends upon this. If this set, adding this set, doesn't change anything, S3 is still linearly independent, then good. Okay, we're saying good because we start off with linearly independent and we add another one, it's still linearly independent. So good, right? Suppose we are after linearly independent set, right? Now S4, suppose I create an S4 here, right? And that's also, we have V1, V2, V3, V4, add another one V5. Aha, if I add this V5, then S4 is no longer linearly independent, right? So this V5 is a type of vector. When I add it, it changes everything in that vector, right? It no longer is linearly independent. In fact, it is dependent now. So sorry, I need to use word linearly dependent. Right, so this is where we stop. So, well, we can't add that, so we go back. So we'll say for the set S1, S3 is the maximal linearly independent set, right? Because adding V4 doesn't change it in the sense that it is still linearly independent. Now it might be well case that vector phi was a vector that doesn't change it anything, it still keeps it linearly independent, then we can say S4 is the maximal linearly independent set. If I have another vector adding V6 to it here, that makes it linearly dependent. Okay, so the simple idea here is, right, let me just write the simple idea. Keep adding new vectors until the superset becomes linearly dependent. Once it becomes linearly dependent, the set or superset prior to this linearly dependent set is called the maximal linearly independent set. Okay, so does that make sense, guys? I hope this has been helpful. So the idea is you think about keep adding and adding and adding, and you stop right once the set becomes independent, and you just select the one just immediately prior to the one that actually changed into dependent. Right? Thank you very much, guys. I hope you enjoyed the video.